One of the things that I love so much about chemistry is the study of change. It's the study of how does a substance go from one thing into a totally different thing. And you may not think much about it, but it happens constantly everywhere around you all the time. If you go to your kitchen and you cook yourself a meal, chances are you're taking one substance and turning it into something new. Think about like cooking an egg. Nobody wants to eat a raw egg. It's disgusting. So you cook it up and it goes from that jiggly, gooey, see-through mess into something totally different that you actually want to like put on a piece of toast. Think about like your car. Starts out as a beautiful, nice thing, and then all of a sudden, a few years later, it's rusting out and falling apart. Like, what is actually going on? Well, chemistry is the study of how that actually happens, and a big part of that is understanding compounds. Compounds really make up much of the world that we see, and there's so many different varieties that end up putting different pieces together. Really, chemistry is about taking 92 naturally occurring elements in the universe, combining them together, and making the entire world that we see. And so that's what we're going to do right now is try and understand those compounds. And we want to start as simple as we can by understanding what categories there are. A compound, first of all, we should understand is one or more elements bonded together. So what I mean by that is it may be like sodium hooked to chlorine or carbon connected to carbon, but ultimately it's having more than one element connected to each other. Now there are different categories of elements, and all elements are bonded, meaning like held together by electrons. And so the first element that I wanted to talk about is what's called an ionic, the first compound is an ionic compound. Now, an ionic compound is made of ions, and hopefully that makes sense. Like, that's the name. It is made of ions. So what is an ion? An ion is an atom with a charge. And how did they get that charge? Well, by exchanging electrons. So how does this actually work? Well, let's look at an example. We're going to talk about, let's say, lithium fluoride. And so lithium fluoride, we're going to have our lithium, and it's going to have its nucleus with its protons and its neutrons. Now, those aren't the important part right now, so I'm just going to color this in. But the electrons are actually the thing that determine the bonding. So we have our nucleus, and then lithium is going to have 3 electrons, so 2 in the first orbital, 1 in the second orbital. You know what? I'm going to move that electron. Let's put it over here. Fluorine, on the other hand, has 9 electrons. So it also has its nucleus. It has 2 electrons in the first orbital. And then it's going to have 7 electrons in the second orbital. 1, 2, 3, 4, 5, 6, 7. Well, an element always wants to have a full valence shell, meaning like the outside ring, it wants to actually be filled. And right now, there's only 1 electron in this outside one. And the fluorine over here is actually missing 1 electron. So this is my lithium, and it has 1 electron in its outside ring. And this is my fluorine, and it has 7 electrons in its outside ring. So here's what's going to happen, is this electron is actually going to move. The fluorine is going to rip that electron away from the lithium. And now it's going to be on the fluorine. Fluorine now has 1 extra electron, which means it has a negative charge. Lithium has now lost an electron. So it has a full outside ring, it's now a different ring. But because it lost one electron, it now has a positive charge. And what do we know about things that are positive and things that are negative? Well, positives and negatives attract to each other. So these literally are held together because they are stuck to each other through a positive negative attraction. And that's what we would call an electrostatic attraction. So that's one type of compound, is an ionic compound. So what's the other type of compound? Well, let's jump over here for a second. The other type of compound is called a covalent compound. And I just want you to think about this for a second. Co is a prefix that means together, and valent means outside electrons. A covalent compound is when there is sharing of valence electrons. So let's think of an example. I'm going to talk about H2, which is technically a molecule and not a compound, but it's close enough. It'll help us understand it. So here's my nucleus, and you know what? For this one, I'm going to write out the nucleus. There is one proton in the center, and hydrogen has one electron. It still wants a full outside ring. So what it's going to do is find another hydrogen. And instead of having that hydrogen just be on its own, they're actually going to share their outside rings. And that way they can each have 2 electrons in that outside ring. And this way, you can actually have 2 elements connected to each other by the sharing of electrons. It's kind of like they're holding hands. They are stuck together because they actually have electrons that are being shared in that outside orbital. So how do you tell the difference between these two? Just by looking. Well, a covalent compound is always made of 2 or more non-metals. So you actually have to have non-metals connecting to each other in order to have a covalent compound. So how do you tell if something is a non-metal? Well, you need your periodic table. On your periodic table, you have this staircase that walks its way down across the periodic table. Everything on the right-hand side of that staircase and hydrogen, those are nonmetals. Everything else on the periodic table, all of this stuff here, these are all metals. If you see anything that is on the left-hand side of the staircase except hydrogen, then you know it's not a covalent compound that's being formed. So how do we tell if something is an ionic compound? Well, using that same idea. If it's an ionic compound, it needs to have a metal and non-metal. So what you want to look for is on your periodic table, does it have something from the left-hand side of the staircase and something from the right-hand side of the staircase? There is another option here that it could have what are called polyatomic ions. So a polyatomic ion, usually you would find by looking at a chart something like this. And polyatomic means many atoms. Polyatomic ion means many atoms with a charge. So I'm just going to zoom in here and let's look at ammonium, which is NH4+. It's actually made of 1 nitrogen, 4 hydrogens, and altogether they have a +1 charge. This is what we would call a polyatomic ion. And if you jump to the other side, you'll notice a whole bunch of them. Acetate, bicarbonate, binoxylate, biphosphate, biphosphite, bisulfite, cyanide, dichromate, all of these things that have more than one atom are polyatomic. Something like Cl negative would be called monoatomic because it's one atom. But that's how we can tell that something is an ionic compound, is it's made of a metal and a nonmetal, or it has a polyatomic ion. This is like a fundamental piece of knowledge that we need to know in order to work with chemistry, because chemistry is all about compounds. And so we need to understand some of those fundamentals about how to identify them and what they actually are in order to work forward. The next step is actually learning how to name and write formulas for them. So that's going to be coming up in the next videos. So make sure you check those out and start learning how to do that, because that's really like learning the alphabet of chemistry. So thanks for watching, and I'll see you next time.